Hi, in this lecture, I'm gonna talk about arrays. Arrays are one of the most fundamental data structures. I'm gonna talk about what are arrays, some common array operations, such as array insertion as well as array deletion, as well as the different types of arrays. And then I'm gonna talk about one common exception or error when we're dealing with array questions or problems, that is an index out of bounds. So let's get started. An array is a kind of linear data structure that uses a block of continuous memory to store a set of data of the same type. And assuming that we have an array of integers of size 100, there are three major components: addresses, values, as well as indexes. The addresses actually represent the physical address of each block stored within the computer memory. And the indexes actually help us to keep track of the position of each block. And the values, it actually represents the values stored within each block. Our array starts with the index from 0 to n-1. When a computer needs to access an element at the index I in an array, it calculates the memory address where the element is stored using the following formula. Address of array element I equal to base address plus I multiplied by the size of data type. In the above example that I mentioned, the base address actually represents the first address of first block, that is 1000. What if we want to get address of second block, that is 16? What we can do is use base address 1000 plus, now the I should be, since the index is starting from 0, the second block, the I equals to 1. And the size of the data type, since the data type is an integer, the size of it is 4 bytes. And now the address of the second block should be 1000 plus 1 multiplied by 4 is 1004. And this property enables the array to support random access, which means we can take constant time complexity to access the value at given index from the array. Now let's talk about array operations. The first one is array insertion. Assume the size of the array is n if we want to insert an element into the kth index of this array. The first scenario is that we insert an element at the tail of this array. If k is smaller than n, that means the array is not full now. It's pretty straightforward. We can simply insert the element at the kth index, and it only takes O1 time complexity and O1 space complexity. But what if k is equal to n-1? That means the array is full now. We have to create a new array and move all the data into this new array first. And this step takes O(n) time complexity and O(n) space complexity to complete. And after that, we can insert the element as a kth index of this new array. Based on the maximum growth rate principle that I talked in previous lecture, the total time complexity will be O(n) and space complexity will be O(n) as well, as we can see in the following picture. Now, what if we insert an element at the head or middle of this array? We have to make the room for the new element. In order to do so, we have to move all the elements starting from index k backwards one step. And this step takes O(n) time complexity and O1 space complexity. And after that, we can insert the new element into the kth index position. It only takes O1 space as well as the time complexity to complete, as we can see from the following picture. So the total space and time complexity will be O(n) time complexity as well as O1 space complexity. Again, if the array is full before we insert this element, we need to create a new array and copy all elements into this new array first. Now let's talk about array deletion. Again, we assume the size of this array is n. We want to delete an element as a kth index of this array. The first scenario is that we delete at the tail of this array. What we can do is to simply delete it by moving the tail one step forward, which takes O1 time and space complexity to complete. As we can see in the following picture, it's pretty straightforward. And in second scenario, that we delete an element at head or the middle of this array. What we need to do is to move all elements ranging from k plus 1 to n minus 1 one step forward, which takes O(n) time complexity and O1 space complexity to complete, as we can see from the following picture. Now, let's talk about different types of array. The arrays we talked about so far are called one-dimensional arrays, where all the data stored inside the array is laid out in one dimension. And data stored inside array can also be laid out in two dimensions, in rows and columns, and this is called two-dimensional arrays. For example, the following is a two-dimensional array. In order to access each element, we not only need to provide the row indexes as well as the column indexes of that. And moreover, the data can also be laid out in multiple dimensions, and in that case we call it multi-dimensional arrays, which means we can access the data by the combination of multiple indexes. And in many programming languages, strings are stored as an array of characters intrinsically, so they are also be regarded as special type of array. And now let's talk about one common exception or error when we're dealing with array problems or questions, that is index out of bounds. Given an array of size n, its index ranges from 0 to n minus 1. And sometimes, if we mistakenly try to access data at the index smaller than 0 or index greater or equal to n, we will get some unexpected behavior or error. And we say that the index now is out of bounds. In some programming languages, there's no guard against indices that are out of bounds, such as C++, which does not check if the index is out of bounds, and we can usually get some dirty data from it. However, some programming languages provide checks for this situation, such as Java. It provides an exception called array index out of bounds exception. Now, to summary, an array is a kind of linear data structure that uses a block of continuous memory to store a set of data of the same type. And one of the most important features of an array is that it supports random access. And typical array operations like insertion and deletion of an element can usually cause data to move, which takes O(n) time complexity as well as O(n) space complexity on average. Though in some special cases, it can only take O(1) time and space complexity. And there are different types of array that we've covered before, such as one-dimensional arrays, multi-dimensional arrays, etc. And strings are also a special kind of array, since they are represented as an array of characters in many programming languages. And we also covered one common error or exception when we're dealing with array problems or questions, that is index out of bounds. Thanks for your attention, and I'm looking forward to seeing you in the next lecture.